Hi guys, welcome back to our discussion on infinite series. Okay, our next topic is about P-series and harmonic series. So, by definition, a second type of series has a simple arithmetic test for convergence or divergence. So, a series of this form, summation of 1 over n raised to p, where n is from 1 to infinity, that if n is equal to 1, then you have 1 over 1 raised to p as the first term. If n is equal to 2, then we have 1 over 2 raised to p as the second term. If n is 3, then you have 1 over raised to p as the third term, and so on and so forth. So this type of series is called a p-series, where p is a positive constant. For p is equal to 1, this series can be written as summation of 1 over n, where n is from 1 to infinity. That if the value of n is 1, then you have 1 over 1 is 1. If n is 2, then the second term is 1 over 2. Plus, if n is 3, then you have 1 over 3 as the third term, and so on and so forth. So this type of series is called the harmonic series. So from the defined harmonic series, now we can generalize the harmonic series. So a general harmonic series is of the form summation of 1 over a n plus b. In music, strings of the same material, diameter, and tension whose lengths form a harmonic series produce harmonic tones. So according to this theorem 9.11, given the p-series of this form, summation of 1 over n raised to p, where n is from 1 to infinity, that if n is 1, we have 1 over 1 raised to p. If n is 2, then you have 1 over 2 to the p. If n is 3, then you have 1 over 3 raised to p, and so on and so forth. So the p-series of this form is said to be convergent if the value of p is greater than 1, and diverge if the value of p is greater than 0 but less than or equal to 1. Okay, like for example, suppose we are asked to discuss the convergence or divergence of letter A, the harmonic series, and letter B, the p-series with p equals 2. So for letter A, given this p-series of this form, 1 over n, where n is from 1 to infinity. And as you can see, the value of p here is 1. And if you can recall, a p-series with p is greater than 0 but less than or equal to 1 is a divergent series. And harmonic series is always a diverging series. Okay, another example, given the summation of 1 over n squared, where n is from 1 to infinity, wherein if n is equal to 1, then you have 1 over 1 squared. If n is 2, then you have 1 over 2 squared. If n is 3, you have 1 over 3 squared, plus and so on and so forth. Okay, this p series is a series with p equals 2. And recall from theorem 9.11 that a p series is said to be convergent if the value of p is greater than 1. So therefore, this series is convergent. So in summary, a series of the form summation of 1 over n raised to p, where n is from 1 to infinity, which is equal to 1 over 1 raised to p plus 1 over 2 raised to p plus 1 over 3 raised to p, and so on and so forth, is a p series where p is a positive constant. For p is equal to 1, the series is called harmonic series. And the series is of this form, summation of 1 over n, where n is from 1 to infinity. That if n is 1, we have 1. If n is 2, we have 1 half. If n is 3, then we have 1/3, and so on and so forth. And to check whether the series converge or diverge, we have to look at the value of p. If p is greater than 1, the series converge. And if p is greater than 0 but less than or equal to 1, the series diverge. So because the value of p for the harmonic series is 1, so we can say that harmonic series is a diverging series.